Hello everyone. Today I will show you how you can create client organization and what is the use case of that in the Xcode UI. So if I first describe what is client org is, it is a like logical separation between clients in one cluster. For example, one client can't create some components, some databases of the other clients, and they both like creating DB in the same cluster, but they can use separate namespace dedicated to them. And in that case, a client organization can be an useful thing. So for the demonstration purpose, I have already created one ACE cluster and imported one EKS cluster onto that ACE. And you can follow my previous videos for like setting this setup. And let's deep dive into the user creation first. So go back to your admin account, go to platform UI. In the platform UI, as a admin account, go to site administration, and you should see the user accounts here. So I have created two user account. One is org1 admin and other is org2 admin. So just create user account and give the username, email address, and password, and maybe click on the unclick that require user to change password, and just do a create user account. So that's it. You will get two admin account, two user accounts by doing that. And next thing I can show you that how we can create the client organization. So go back to user settings, click on client organization. You are acting as the admin now. Click on add organization, and here you need to put the org name. So the as the user, as I showed you, that org1 admin, that password was this one. Let me show that first. Yep, this org1 admin, its password is org1 admin, and that org2 admin, its password is org2 admin. So let's back to work. Click on add organization. Let's say I'm giving the org name as org1, and that org1 admin, that is the organization admin that I'm going to make. Click on next. We need a hub spoke model. So as you have already watched my previous video, in that video I showed you how you can import an EKS cluster as a spoke with the ACE cluster. So in that case, our hub cluster is the ACE one, and our spoke cluster is the EKS test that we are using currently. Now configure the node pool section. These node pools actually refer the levels of the nodes. Those nodes will be used for this organization, this org1 only. So as I already said, this is a logical separation, right? So this org1 admin can use this org1 org, and this org1 organization is only associated with some nodes. Those nodes can't be used by other organization. That's the purpose. So we need to give the levels of the nodes that is going to be used by this organization. And for that, we need the levels and taints. So I have created already some nodes because that is like time consuming. So let me show you how we can create it, the nodes in the EKS. Here, as I created the cluster with cluster API. In that case, I am like utilizing the copy resources like AWS managed machine pool, then the machine pool, those resources I have created. If I describe a little bit, here I'm going to use this EKS test cluster. My instance type is C5X large, and the node group name is I'm giving org1. This is the role name that I just copied from the default node group. And here, this is the important section. Here I have set the labels of the node to be org equal 1, and the taints of the nodes to be deployed to org1, like so. And I'm giving the preferred schedule effect. And here in the machine pool section, you can see that I'm using the cluster name EKS test, and the replicas is 1. So I'm going to create one node in that node group, and its maximum size can be 2. And I'm going to use this previously applied AWS managed machine pool, this object. So I have just created these two objects. So let me show that in the cluster. If we get the machine pool object, this is the machine pool object that I have created with replica 1. And if I get the AWS managed machine pool object, this is that one. So max size is 2, minimum size is 1, and this is the instance type, and so on and so forth. So once I have applied this with the copy enabled, I have showed that these are the nodes that have been created. So this is the latest node that I have just created with this resource, applying this resource. And here you can see that this org1 levels has been added. And if we get the YML of that node, because the other two nodes are like for the default node group, and this one is for this org1 node group. So let's show the YML of that one. And here you can see the taints has been perfectly assigned, and the levels too. So if you don't watch copy, you can just go to your AWS console. Obviously, there is always a way. So go to your cluster, EKS cluster, go to compute section, and create the node groups accordingly. So when you create the node groups, you are able to give the Kubernetes levels, Kubernetes taints, tags, and whatever you want, choosing the VMs to where the node groups will be deployed, what is the size, what is the machine configuration, those stuff. So once your nodes are ready, you can use those labels here. So I'm going to use that one. So my label is org1. I know that. And the toleration, I can keep no execute. Let's keep it prefer no schedule. That is the minimal one. And its value key was deploy to, because this is the value I have used, as you can see. Yes, this one deploy to org1, and it was org equal 1. So it is deployed to org1. Save it. So our node configuration setup is done. Click on next. Now we're going to use the gateway, that how those databases assigned created by the client organization, created for the client organization, can be exposed through gateway. So I'm going to use a dedicated gateway for client organization, because I'm keeping everything is as a logical separation on everything. So I'm going to use a dedicated gateway, and don't want any custom gateway, existing gateway existing. So I'm going to manage my gateway on myself, and I don't want to actually start I want to preload existing one and just modify that one. So I'm going to preload the ACE one, because this is already created in my cluster, and if you can I can show you that obviously. So this is the gateway presets that's already in the cluster. And I'm going to just modify this one and create a new one from that. So the host type will be domain, because I'm going to create a load balancer. Here you can see that Envoy service is of type load balancer. So I'm going to create a load balancer service, and I'm going to expose the Postgres, MongoDB, MySQL, whatever databases in different ports of that load balancer IP. So that's what I want. So AWS by default, if we create ELV, so I can show you that. Go to load balancer. This is easy to picture. And here you can see that AWS create a DNS name by default, which is of structure like some hash and then the region and then ELB, AWS, Amazon AWS.com. So this type of load balancer will be created once we apply this client organization. I have not submitted yet. And once it is done, that created load balancer on the AWS console will be used to actually expose the databases. So basically, we need to add a CNAME. Let me show you how we can do that. Let me first keep the host name as domain, because this is a domain. It is clear. It is a domain. Now we need to give the host name as we don't know the host name, because that will be created on the fly. So we need to manually create one CNAME record in our Cloudflare, or AWS Route 50, whatever you want. I prefer using the Cloudflare. So I'm going to use my kubedb.cloud, this domain, to actually expose the databases. So I'm going to name it org1.kubedb.cloud. That will be used for accessing the databases. So I'm going to put that one. As you know that is not created already. So I'm going to create that also. And once these stuffs are done, it is a load balancer, external traffic policies cluster. These are the default ports, so don't need to change that. Everything is good. So click on submit, and these are the internal CS, so no problem on that. This is the infra CA. So I'll show that what is the use case of that one. So click on submit. That one, as you know that is not created already. So I'm going to keep. And once you have submitted, go to the cluster and show the namespaces. Yep. Here you should see that 3 new namespaces has been created just for creating the client org, and they are org1, org1 gateway, and org1 monitoring. So all the databases will be go on this org1, and this is the main namespace that will be used by the org1 users like org1 admin or so. And these are the dedicated namespaces to be like holding all the gateway components and monitoring components only. So if you now get the ports in the org1 namespace, org1 gateway namespace, and you should see that everything is up and running in the like gateway components, like Envoy gateway. Then the actual service, I can show you that service because that is the main thing. And once you have submitted, go to the cluster and show the namespaces. Yep. Here you should see that 3 new. Here you should see that this load balancer service has been assigned by the AWS, and you should also confirm that from the AWS console too. So just do a refresh here. And yeah, so this is the load balancer, ELB load balancer has been created by the AWS, and we are going to use this LB to actually expose all of the databases in the client organization. So before that, as you remember that we gave kubedb.cloud as the domain name. So what is that? That is in the YAML of this Envoy gateway service. Here, this one. So this kubedb cloud has been appended by the organization name. So this org1.kubedb cloud, this is the actual host name that will be showed in the UI when like accessing some databases. So we need to create a CNAME between this DNS and this one. So let's create one in the Cloudflare. I'm in the kubedb cloud, creating a DNS record. The DNS type is CNAME. Okay. Here the name should be the org1, because if we give org1, that will be like org1.kubedb.cloud. We're inside the kubedb cloud, and the target is just copy the name of this one. So the second one is the correct one, I think. Let me just confirm. Yeah, the second one is the correct one. So just copy and paste. I'm removing the proxy and save. Perfect. So we have added the CNAME. Now it's time to like create as a org1 admin from the AppScode Cloud console, and let's try the databases things out. So I'm going to log in as a incognito in a incognito window. Just let me just copy the IP. So I'll log in as a org1 admin now. Perfect. So as a org1 admin, if we see what is happening here, go to the organization or user settings. Here you can see that this is the admin account and this is the organization. So I'm switching back to my organization. Go to my KubeDB UI. And here, if we try to create new instance, like for example, I want to create a PG, and here you should not see any other namespace of the cluster, because as you know that there are like many namespaces there, but this client or admin can't use that one, none of them. So he's like binded only on this, and these two, he even can't like use this two also, because these are like for the gateway and monitoring stuffs to be used by the operators. So that should not be used by the client organization admin too. So let's create one here. I'm keeping the name as PG1, for example. Creating HA cluster. I'm just enabling the TLS and expose that via gateway. So that's it. Very basic PGYML, and enabling the backup too. Perfect. Now I am going to do the same thing for org2. So first I need to create these stuffs. So let's rename this one. It should be org1. Should be replaced by org2. Name is org2 to org2 org2. Perfect. So let's apply this one to make the nodes. So some nodes will come up. Now we're going to create another client org from the admin account. Similar stuffs. I'm just repeating. It is org2, so I'm keeping the org2 admin as the main organization admin. The same cluster we're going to use. Here it should be org2, I think. Let me just recreate, I think. In the YML, it should be org2. Nice. So everything is active. So these org2 nodes should be usable. And if we just confirm that has been created, one is org1 and this one is org2. Perfect. So let's continue to create the client org. Here it is org2, which is okay. And here I will keep them as it is. Deploy to existing org2. You can edit this one again. I want to make it no execute. Click on next and do the same thing to create the gateway. Just preloading from existing one, this ACE1. And let's make it KubeDB Cloud. This should be the domain. And here are the some other fields that I already, I think, described. This is the in-cluster configuration. So I don't have any external use cases. So I'm not going that one. And this is the load balancer service we created. The external traffic policy will be set on that Envoy load balancer service that is going to be created. And these are the port range to be used for exposing the databases. And the provisioner type is deployment. So if you like use demonstrate, in that case, the Envoy ports will be running on each nodes of that organization. But I don't want that. I just running that as a provisioner type deployment. And in the infra section, if the DNS provider want to like create the DNSs on the fly, you can just go with some other options. But as I'm doing it manually, I'm just choosing DNS provider none and giving the host type. And as you already know that this KubeDB cloud will be like org2.kubedb.cloud. So after submitting that, I will just add another scening. Okay. Finally created, and we should see the namespaces here. Perfect. And we should see the service also. It should be org2.gateway. So this external IP is pending. So one IP DNS will be assigned by the AWS console. Yep, it got assigned perfectly. And let's confirm that from the AWS console also. Go to AWS console, go to EC2 dashboard, let's say, and in the load balancer IP, you should see that has been just created right now. This one. So let's copy this one and add another CNAME record. It should be CNAME. The name should be org2, and the target value is that one. Removing the proxy and saving that. Perfect. So the org2 setup is already done, I think. So let's create one. I'm going to like open up another incognito window and just log in as the org2. Okay. Going to sign in as a org2 admin, and the password is same. Perfect. So I've been logged in as org2 admin and going back to my organization, and this is the KubeDB UI. So let's create one here too, and going for the police also here. Let's name it PG2. Everything as it is, not changing anything. Just enabling the TLS, exposing via gateway, and click on deploy. Perfect. So here, as a org2, and I'm as a org1 there. So let's see from the terminal if the PGs are running. Okay, so the first one was ready, and this one is getting provisioned. Let's say what are the pods, if the pods are coming up or not. Yeah, the pods are coming up correctly. So let's wait for this to be ready. We are going to then using the exposed URL, we're going to connect after that. And here, one thing obviously notable that you don't see the PG1 here because you are using, you are logged in as a org2 admin. Let's do another refresh. It should be ready by this time. Okay, all the ports are running, so it should be ready by now. Let's give some more seconds. Yeah, it is ready. So let's go back to the UI. I'm seeing the org2 one. So go to the PG2. Yeah. And we're going to use this URL as the host name is org2.kubedb.cloud. That is going to be used for this org2 organization. So let's copy the CSR first. I'm going to keep this in a file. So let's let's name it org2 ca.crt. This is actually org2 envoy ca. And let's copy the URL. Here we need to change the CA name here. So this is org2 CA envoy. Perfect. And you can see that I have successfully got connected, and we can like run some PSQL command onto that. And similarly, you can connect to the org1 also. So just logged in as a org1 admin, and you should see the similar kind of URL, connection URL, and just run the PSQL command, and that's it. So far so good, and everything is running, and this org2 user can see the org1 stuffs, and same for the org1 admin too. And if we go back to the admin user, so I'm just cutting this down. If we go back to the actual admin user, Go to the KubeDB UI. We need to switch back to the organization apps code. And you should see that all the databases that was running as an organization, those are running here too. So that's what for today. So yeah, try it yourself and have a good day. Nice. So everything is active. So these org2 nodes should be usable. And if we just confirm that that has been created, one is org1 and this one is org2. Perfect. So let's continue to create the client org. Here it is org2, which is okay. And here I will keep them as it is. Deploy to existing org2. You can edit this one again. I want to make it no execute. Click on next and do the same thing to create the gateway. Just preloading from existing one, this H1. And let's make it KubeDB Cloud. This should be the domain. And here are the some other fields that I already, I think, described. This is the in-cluster configuration. So I don't have any external use cases. So I'm not going that one. And this is the load balancer service we created. The external traffic policy will be set on that Envoy load balancer service that is going to be created. And these are the port range to be used for exposing the databases. And the provisioner type is deployment. So if you like use demonstrate, in that case,